We've been graphing quadratic equations for quite a while now. Today what we're going to be doing is graphing quadratic inequalities. An example of a quadratic inequality is that the equal sign, instead of saying y equals 2x squared minus 6x plus 5, we would have y is greater than or equal to 2x squared minus 6x plus 5. The graphing is going to be very similar to graphing what we would call normal parabolas, with two exceptions. So it is just like graphing normal parabolas, except we have to pay attention to the symbol because it's going to tell us two things. If we have a greater than or a greater than or equal to symbol, these are both going to mean that we shade above the parabola. But if we have a less than or a less than or equal to, we are going to shade below the parabola. Now that's one exception to the different graphing rules. The other exception is that if you have the greater than and less than, that's going to be a different representation than having the greater than equal to or less than equal to. If you have a greater than or a less than, then what you're going to do on both of these is you're going to draw a dashed parabola. But if you have a greater than, equal to, or less than equal to, that is going to be a solid parabola. Now these graphs are going to look different depending on whether your parabola opens up or opens down. On the shade above the parabola, if your parabola opens up, then you're going to be shading above the parabola, which will be inside. But if the parabola opens down, then you're going to be shading above the parabola, which would be on the outside. On the parabolas that you shade below, if your parabola opens up, then you'll be shading outside. But if the parabola opens down, then below will be inside. It's going to be really important that we remember that these symbols are the determining factor in how we're going to draw our parabola and how we're going to shade our parabola. So make sure that you have those straight. Then we're going to look at a couple of examples of how to graph these. So keep this handy as we move on to a piece of graph paper. Now we can work with either standard form or vertex form in graphing these quadratic inequalities. This particular one is in standard form. Now you're going to be really happy to know that we don't have to go through all the 15 different steps that we've been working with to graph these parabolas, because really all we have to have is the graph. We don't have to have the x-intercepts and the y-intercepts and where it's increasing and decreasing and positive and negative and all those things. What we really just need to do is have a sketch of our graph. And we can tell by looking at this parabola in standard form that the a value is 2. Now that is really important because it tells us a couple of different pieces of information. Because a is positive, that tells me that the parabola opens up. And since a is 2, that tells me there's a vertical stretch of 2. So the pattern that I'm going to use after I find my vertex is I will be moving from the vertex over 1 and up 1 times 2, over 2 and up 4 times 2, over 3 and up 9 times 2. So then that just really leaves me needing to find my vertex. So we'll go ahead and find the vertex. Now since it's in standard form, the x-coordinate of the vertex is going to be the opposite of b over 2a. b in this problem is -4, so our x-coordinate will be the opposite of -4, which will be +4, over 2 times a, which is 2. So our x-coordinate is 4 divided by 4, or 1. So my vertex is going to be at 1, comma, and then to get my y-coordinate, I'm just going to plug in 1 for the two x's here. So I get y equals 2 times 1 squared minus 4 times 1 minus 1. So y equals 2 times 1, which is 2, minus 4 times 1, which is 4, minus 1. And then subtracting left to right, 2 minus 4 is -2, minus 1 is -3. So my vertex is at 1, -3. I'll graph my vertex at 1, -3. And then from there, I'm going to follow that pattern, over 1, up 2, over 1, up 2, and then over 2, up 8, over 2, up 8, and then over 3, up 18 is going to be way up here. Like way up here inside my work for my problem. So I'm not going to worry about sketching that point. The other things I need to pay attention to are this inequality symbol. Since it is a less than or equal to, that tells me two things. The first thing, since it is less than, that means I'm going to shade below my parabola. And the other thing, since it has that equal to, that means I'm going to draw as a solid parabola. So when I go to connect my dots, I know I'm using a solid line to sketch my parabola. And I'm going to be shading below, so everything that is below that parabola on the coordinate plane would get shaded. It's a lot of coloring. You might want to use a crayon. And that's the end of that problem. And we can also graph quadratic inequalities that are in vertex form. In fact, vertex form is probably easier. Because when our equation is in vertex form, or our inequality in this case is in vertex form, we can just list the transformations and graph from there. So the transformations from the parent graph, which is just y equals x squared, we have a shift to the left 1 unit. We have a shift up 5 units. Now these two shifts together are going to tell us where our vertex is at. Normally the vertex is at 0, 0. When we shift it left 1, that puts it at -1, and when we shift it up 5, that puts it at 5. So our vertex is at -1, 5. The other transformation we have is this right here, which is a reflection. that means that the parabola opens down. So the pattern that we'll use when we graph, instead of going over 1, up 1, we're going to go over 1, down 1, over 2, down 4, and over 3, down 9. The other thing that we need to watch for is our inequality symbol, which is a less than. That symbol being a less than tells us two things. One thing it tells us is that we will shade below the parabola. The other thing it tells us is that we will draw a dashed parabola. Okay, so let's go ahead and get that sketched on our coordinate plane. The vertex is at -1, 5. And then the pattern is to go over 1, down 1, over 2, down 4, and then over 3, down 9. Remember that we're going to connect this with a dashed line, rather a dashed parabola. Oops, I scooted over too far, that one. And then we are going to shade below. In this case, below the parabola, below the dashed line, is going to be inside the parabola. And that's that.